go on to the next one, which is hierarchical attention. So again, something very popular and nowadays become very common for various things. So again, not a very difficult idea to understand. So let's first look at the motivation for this, and then we'll look at the solution. So consider a dialogue, right? Today everyone is interested in building chatbots. Every second startup wants to build their own chatbot, and every second startup out of that wants to build it for the agriculture domain or the banking domain or the healthcare domain. So here's what a typical dialogue looks like, right? This is of course not for any profound purpose. But you can see this is an important dialogue, right? Very relevant and very important. So yeah, so this is what a dialogue looks like. So let's try to break it down into the kind of entities that we deal with. So can you tell me about a dialogue? What is a dialogue? It's a dash. Think in terms of things that we have discussed so far. Sequence, good, right? Again, the safest answer is sequence from now on. No, it's only for one lecture. Is it just a sequence or sequence of sequences, right? So it contains a sequence of utterances. So each of these lines here is an utterance, and each utterance in turn is a sequence of words, right? Okay. So what we have here is a sequence of sequence as input, and this is very common in many applications, right? So can you think of an encoder for such a sequence of sequence? RNN of RNNs, good. That's the answer, right? So we think of a two-level hierarchical RNN encoder. So the first level will encode the utterances. Okay. Let me ask you a few questions. Is there a mistake in the diagram? Should this be connected? Yes, no, maybe, don't care. Okay. Second question. I'll write some parameters here, right? What's our notation? W. This is U, right? And this is W, right? Is this fine? If I have a dialogue which contains 100 utterances, what will happen? That's the practical problem, but more conceptually, what is wrong here? What is each RNN trying to do? Encode a sentence, encode an utterance. So why should it be different for the first utterance, second utterance, third utterance, and so on, right? All these RNNs should be the same. Does that make sense? So U1 is equal to U2 is equal to U3, and W1 is equal to W2 is equal to W3. Okay? Is that fine? Everyone agrees with that? So now can you tell me if the correction should be there or not? Conceptually, what is each RNN doing? Encoding one sentence, right? Then why should it be connected to the previous sentence? But then if you don't know all these sentences, then how will you predict the utterance, the next response rather? What is missing here? What was the title of this module? So what is missing? Where's the hierarchy, right? So what you'll have is this, right? So each of these green guys is representation for one utterance in your input. In fact, the red guys, sorry. The red guys are the representations for the utterances in your dialogue, and then the green guy is a sequence of utterances, right? So remember, you had a sequence of words. So the red guys are the sequence of words, and the green guys are the sequence of utterances. Does that make sense? Okay. How many of you get this? Please raise your hands. Okay. Good. And now, what would the decoder be? You have a hierarchical encoder. What would the decoder be? What does the decoder have to do? It has to produce everyone sequence of words. So what kind of a decoder will you use? Just an RNN, not a hierarchical RNN. But the input is hierarchical. Why shouldn't the output be hierarchical? How it would look unbalanced. Right? The diagram will not look very neat, right? If you have this. Do you need a hierarchical decoder? No, right? I mean, it's just a simple decoder because the decoder just has to produce a sequence of words. So it will take something from the encoder. What will it take from the encoder? In the normal encoder-decoder paradigm, not the attention-based paradigm. What will be the input to the decoder? The last dash vector. Your options are, state, that's a very safe answer, yeah, the last state vector, whatever that means. Yeah. Your options are orange, blue, green, and red. Green, the last green vector, right? That's what the input is going to be, right? So this is what it's going to look like. This is option 1, what's option 2? Feed it to every time step, right? That's what option 2 is going to be, okay? So that's, you have your hierarchical encoder-decoder network. What's missing here? Attention, okay? So let's look at another example. Consider the task of document classification or summarization. What's the difference between two? In classification, what would the decoder be? Feed-forward neural network with the softmax. What would the decoder be in the case of summarization? RNN, good. What's a document? Sequence of sequence, not sequence of sequence of sequence. It can be a sequence of sequence of sequence also, right? Oh, I didn't think of that. Then it could be a sequence of sequence of sequence of sequence. Okay, let's look at the not so funny case, which is sequence of sequence. What is a sequence of sequence of? It's a sequence of sentences, which in turn is a sequence of words, which in turn is a sequence of characters. But we'll not go there. Okay, we'll just keep it till words. So it's a sequence of sequence. So again, you need some kind of a hierarchical encoder here, right? So you'll encode each sentence. Then you will treat the sentence sequence as a sequence, encode that, and then you will pass it to the classifier. Okay. Now think of this problem, right? Now if you want to do document classification, how would you go about it actually? You want to classify whether this is a politics or a sports or health or whatever genre. Think in terms of attention. What would you do actually? First you will find the important words in the sentence. To find the important words, you'll have to read all the. If you want to find the important words, you'll have to read all the sentences. So what will you do? First find the important sentences and then important words within the sentence. So what kind of an attention mechanism do you need? Hierarchical, right? So let's look at this. So first let's look at the our data model paradigm. So what's the data given to you? Given a document and the class label for the document. And your first thing is the word level encoder, which looks like this. I'll not explain what this is, I'll just expect you to know what this is. Why do I have two indices for H? What is I and what is J? I is the dash ID, sentence ID. And so it's the jth word of the ith sentence, right? That's what I'm encoding. And how many sentences am I encoding? The number of sentences in the document, okay? And what is the second encoder? So the diagram is absolutely clear, but the equations are not. The diagram is absolutely clear, right? There's no, just need to map the red, blue, orange, green guys to the equations. Okay, so let me ask you this. What is Hij? No, in the diagram. Blue, red, orange. What is Wij? How did we write the RNN equation? Time step t is equal to RNN of t minus 1 and the input at time step t, right? What's the input at time step t here? Word, right? Probably this was not a good choice. Maybe we should make it Xij. W, I think people are getting confused with the weights. They shouldn't, but they are. So, fine. So, Wij is actually the input word. What is Hij minus 1? Now tell me what color is Wij. It's like an IQ test, right? Which color? Map it. Wij maps to which color? Orange. Good. And Hij? Blue. But what about the red? That is which color? I mean, sorry, not which variable? Hiti, that's the last state of every sequence, right? Ti is the length of the ith sentence, right? Okay, now what about Hi2, the green guys, right? And what is this? H2K, the last green guy, this guy. Okay, is that fine? And then the decoder is just our softmax, we don't need to go over that, and loss and everything is fine, right? So this again, whatever it is, you should always be comfortable in writing the end-to-end equations from x to y, right? And you can write it in this case. Now let's make it a bit interesting. How would you model attention in such a hierarchical encoder-decoder model? How many attention functions would you need? Two. One for attention over sentences, the other for attention over words, okay? Can you think of these equations? Not a very big stretch from what we have done already, right? I mean, at level 1 it should be straightforward. At level 2 just ignore level 1. How many of you can imagine the equations? It's not very hard, I'm not joking, I mean just think about it for a. I mean the level 1 should be straightforward because that's just the same as, okay. So first we need to attend to the most important words in a sentence and then we need to attend to the most important sentence in a document, okay. Let us see how to model this. So you have document, again the same input, then you have the word level RNN, okay. Now what would the word level attention equation look like? I'm looking for the attention equation for words. What are the indices going to be? J, I, J, T. Okay, what is I, J, T? Yeah, so that's, I have put that as superscript, right? W. This is the word level attention. So at the tth time step, I want the importance of the jth word, right? What would that equation depend on? the word should be straightforward, right? It should depend on, okay, sorry. This is only for this guy, right? Okay. So we're focusing on one of these. So we're trying to find the importance of these three words, right, which are there in the first sentence. So you have computed Hij, that means you have computed all the representations for each of these words. That means you have computed the first three blue vectors that you see, okay? And then you're computing the attention. Oh no, sorry, this is, so instead of having it here, this is how we have been writing it, right? Oh, okay. Oh, sorry, I should have checked this. So read this as Uij is equal to, or let me just explain it. So remember, this is a vector and we wanted to do this operation to make it a scalar, right? So UW is that parameter which was getting multiplied earlier, right? So we had this attention equation as UW transpose tan H of something, right? So now that UW has been removed from here in equation 2 and has been added as exponent to equation, to the alpha equation. Is that okay? How many of you are completely confused? Please raise your hands. How many of you understand this completely? For once, can the sum be 1? Okay, shit, what did I do? Okay, let's just see if I can still salvage this. Okay, let's go one by one. So what is, let me just delete some of these things. Let's try to write it on our own, right? So this is what we are trying to do. So I'm ignoring the sentence ID, right? So this is sentence 1, 2 and 3. So let's just focus on one sentence and the same equations will hold for the other sentences also, okay? So first of all, the attention weight would depend on what? It would depend, what are we trying to pay attention to? Words. So it should have word in the input, right? What else can you have in the input? Previous state. Unfortunately for this problem, do we have a previous state? No, we are just doing one prediction, right? There is no RNN here. This is just a feed-forward network. Do you have an ST minus 1 in the output? Yeah, that we have put here. So this was the importance of the jth word at the tth time step. So j belongs to the input and t belongs to the decoder, right? In this case, does decoder have multiple time steps? There's only one time step of the decoder, right? That's the problem which we have run into. But let's assume instead of classification, we were trying to do summarization. That means we are given this document and we were trying to generate a summary of this, and let's say the summary was the following. Okay, so this is the summary that you're trying to generate from this document. Okay, and now this summary has 3 or 4 time steps if you count exclamation as the last time step. Now how is it going to be? What is your decoder going to be in that case? RNN, right? And the decoder will have some k time steps. Okay. Now at every time step, at a given time step t, what am I trying to do? Your next assignment, try to develop a better eraser for this. Okay. So we want to compute the attention for a word, the jth word in particular, at the tth time step, right? And we have, for a minute, understood that we don't have a feed-forward network at the decoder. We have a recurrent neural network at the decoder because we're trying to generate a summary. Okay, we're trying to generate a sequence at the output. So at the tth time step, we are interested in understanding which of the document words to pay attention to. Okay, so now that is going to be a function of what? And I find it a bit irritating, for the want of a better word, that at least one input to this function should be straightforward, right? What's it? The word that you're trying to learn how much attention to pay to, right? So that should be very straightforward. So that should be W1J because I'm considering the first sentence right now. Okay, is that fine? For the first sentence, I'm trying to find out which are the words which are important. What's the second input that you could put in? It should depend on the index T, right? So it should be the previous state of the decoder. Okay, and then of course I'll have this is again actually not alpha but E, right? And then you get, how do you get alpha from there? How do you get the alphas? Softmax. Is that fine? Okay. So alpha will be some softmax of the E's. Is that okay? Fine. So this is for the word level. Now the equations that are written on the slide are slightly Okay. So the equations on the slides are slightly differently written. So let me just go back and write our own equation, right? So we want to write an equation for this. What was our equation? Ignore the equations on the slide. It was something like this: V transpose tan H of W ST minus 1 plus U W1J plus B. Okay. Now imagine that your decoder is a feed-forward neural network. What will be missing in that case? There is no ST minus 1. There is no previous state of the decoder because you just want to make a prediction once by paying attention to all the important words and sentences in your document, right? So which part will go away? WST minus 1. Okay, fine. Now, the other thing that you were doing is alpha was actually, or rather alpha ij was actually exponent of Eij divided by summation of, or rather k, no wait, sorry, alpha jt ejt ekt. Is that fine? This is just the softmax equation. Is that okay? Right? Now the only thing that you see different in these two equations here is, first, you don't have the WST minus 1 because the decoder only has one time step. And second, we have taken out this V transpose from here and instead we have added it here. Is that okay? Does that make sense? Okay, this is just a different way of writing it. So can you write the attention equation for the words now? Okay. Now what about the sentence? Okay, now first of all, earlier what were we using for the green guy? What was the representation for the green vector? It was the, what was the green vector? In the absence of attention, what was the green vector? HTI, right? The last time step of sentence 1. Is it fine? Everyone with me? Please raise your hands if you are with me. Okay. Now what would it be? It would be a dash sum of W vectors, a weighted sum, attention weighted sum, right? So that's exactly what this equation is capturing. So what it is saying is that the representation of sentence I is the weighted sum of the representations of all the words in that sentence. Is that okay? So that way we'll get a representation for S1, S2 up to S capital K, all the sentences that you have. Okay. Now what do we want to do? For the second level, what do we want? We want to compute the importance of that sentence for the tth time step, right? So let's call that beta. So I'm interested in beta. We need to really rework this, right? Again, alpha is being used at both the places, right? So I want to find out the importance of the jth sentence at the tth time step. What is it going to be a function of? One is the sentence representation. What's the sentence representation given by? Sj. And what else? The decoder state at the previous time step, right? Does the decoder have a previous time step state here? No. So it will just depend on Sj. And that's exactly what this equation is capturing, right? And again the same trick that I have added this extra parameter to the exponent. Is that fine? And the final representation being fed to the feed-forward network is a weighted sum of the sentence representations, right? So this again has to be Si, alpha I into Si. Okay. Really sorry about this, but I am pretty sure that once we correct the slides and you go back and look at it, it should be clear, right? It's just two sets of equation, one set of equation, sorry. Oh, sorry, that's correct. Yeah, sorry. So just the idea is there are two sets of attention mechanisms. For each you will have their own set of equations. The basic form, if you can work out what the F attention would depend on, the actual form would differ from paper to paper or toolbox to toolbox. That doesn't matter so much. You just need to know that you have these as the input. You're going to add some parameters to every input. That means you're going to do a linear transformation. And then you should just need to make sure that alphas eventually turn out to be scalars, right? That's why you'll have this additional vector getting multiplied at one point, okay?